I want you to close your eyes for just a moment. Imagine a piece of clothing, something you've always wanted. Maybe it's a superhero cape, or a long flowing dress, or even a funky hat. Now make it light up. Add a series of lights around the trim or the collar. Make them pink, or better yet, a rainbow. Now, I want you to go make this. This is the task we gave to 23 high school students in the Twin Cities area this past summer at Upward Bound Camp. Not only did they take on the challenge, but the results were awe-inspiring. A Red Riding Hood cape with LEDs around the trim that would light up when she pushed a button at the end of the runway. A romper tailored to perfection that would alternate between blue and orange lights depending on the beat of the music. And how could I forget this black tulle skirt with blue lights wrapping around? They'd light up when she twirled. And of course, you can't make wearable electronics without a fashion show, both in the light and the dark. Okay, so this project, this experience, it really stuck with me, even as I returned back from summer break and to my regularly scheduled school year. But why? I've grappled with this question since. The conclusion I've come to is that this project was an example of real, authentic, get your hands messy, make mistakes, not quite sure where we're going to end up, sort of learning. Students learned how to sew under the guidance of expert sewer and teacher extraordinaire India Carlson.
So at the start of our project, we surveyed students and found that the majority of them had zero sewing experience. And if you would have told me that in 2 weeks we could take students with zero sewing experience and not only would they be sewing, but they would have drafted and designed their own patterns to fit themselves, I would have said there was no way, it would be impossible. So I was amazed at how much the students got accomplished in such a short period of time.
Kids were learning to code in order to program the LED strings. At first, just to turn the lights on and off, then to blink, then to respond to a sensor, and finally whatever wild pattern their hearts desired. They were even engaging with the engineering design process without even realizing it. Fellow teacher Leslie Anderson recalls,
I remember that we did a gallery walk where students posted their designs on the walls and hung it for review, and other kids got to walk around and they got to comment on what they loved and what could be improved. Almost every student redesigned some part of their drawing after that, and it was really awesome to watch them optimizing just like engineers do.
And all of this designing and sewing and programming was happening because the kids genuinely wanted to bring their design to life. It was theirs after all. They took ownership over their garment, and as a result, each and every kid was intrinsically motivated to learn the necessary skills to make it a reality. It was a glorious mess of learning, where failures were necessary and embraced. It was true learning, engaging with skills that real scientists use daily: collaboration, critical thinking, problem solving. A huge reason this experience was so fun and so satisfying to be a part of was the amazing team of teachers who made it all happen. I was joined by Dr. Jim Madsen, professor at the University of Wisconsin-River Falls, teachers Eric Moose, India Carlson, Steve Stefanowski, Leslie Anderson, and undergraduate student John Incha. When we set out with this idea, we honestly had no clue where it would end up or what it would turn into. How realistic was it to have each kid sew their own piece of clothing? Would the LEDs even attach to the garments? How do you program them in the first place? As Steve Stefanowski remembers,
throughout the project, we're learning alongside the kids, in most cases admitting when we don't know something and figure it out together with them. Our role as teachers was not to know all the answers, but to be transparent learners who could guide the kids. As a teacher, we met at a minimum of 3 times a day, planning in the morning activities at breakfast and the afternoon activities at lunch. This was helpful, and it also helped us to stay very responsive to the students' needs.
The kids' authentic learning was a reflection of our own authentic learning as teachers. We didn't have all the answers, and that was not just okay, that was expected. I think you get the point. It was a really great time, full of student learning, teacher collaboration, and really responsive teaching. And yet, I'd be fooling myself if I didn't recognize the many things that made this experience unique in comparison to a more traditional science classroom during the school year. We had resources, time, a motivated, captive audience, a high teacher-to-student ratio, the list goes on and on. But buried inside this unique environment are some lessons that we can all take back to our classrooms. Eric Moose shares his teaching philosophy.
Students learn best when they're motivated to do so. Whether it's this wearable electronic project, or putting an experiment on a high-altitude balloon, or building a harmonograph that makes periodic patterns, I try to incorporate these hands-on experiences as much as possible in my teaching. Want to talk about zero gravity? Let's build a robot and put it on NASA's Vomit Comet airplane. Want to talk about electricity? Let's make an electric car and race it.
Teacher India Carlson reflects back on this experience and what she's learned.
My own view of what an engineer is and what they do changed, and it broke down some gender bias for me around what engineering is and who can be an engineer.
Dr. Madsen offers another perspective.
Our Upward Bound experience teaches students about cutting-edge science in a unique way. They don't build a neutrino telescope, of course, but they do reproduce the steps it takes to carry out a big project. The trick is to connect what they do to the content we want to convey. We get the students engaged so that they learn a little more physics and develop a lot more confidence.
And me? I'm left inspired by this experience. I returned to my classroom more motivated to design projects and experiences for my students, while incorporating the content in a meaningful, real way. Turning the classic physics egg drop, drop an egg, see if it cracks, into a challenge to design the most effective cell phone case. And taking a classic physics lab of dropping a coffee filter and turning it into a challenge to design the best parachute for a skydiving team. And through these projects, I'm reminded that students, teachers, people in general, really love having the chance to learn and build something together.